So Module 2, Homework 3, we're going to talk about functions. So let's start with a little bit of vocab here. So we have a relation is a set of ordered pairs. I don't know if I can fit that in here. Then in that relation, we have our x values, which are going to be the domain of a relation. Then we have our set of y values, which is going to be the range. So we have this relation below. We want to find the domain and the range. So for the domain, we're just going to list out our x values separated by a comma. So we have x values of -2, 3, 0, and 6. And then our range, we'll just list out our y values. So we have, let's see, 1, 0, -4, and -1. So basically there, if we know how the ordered pair is written, x, y, we should be able to find the domain and the range. Now, some relations are functions and some are not. So to determine if they are functions, you're going to look at the domain and only the domain. Here is your rule, okay? A x value cannot repeat in order for a relation to be a function. Okay, so you're going to look at the domain. You're going to say if any x values repeat, the relation is not a function. So if I look at my two examples here, if I look at my first one, I'm going to look at my x values, and I have 1, 2, 3, and -1. They are all different, so here I can say that yes, this is a function. Okay, so if they're all different, the relation is a function. If I look at this next example here, I have -1, -2, 0, and -1. I have repeaters with my -1s. So here I would say no, this relation is not a function. So I'm only looking at the x values. I'm ignoring the y values when looking at this, just the x values. Okay, so let's look at an example with a graph. Now these are just points on a graph. So let's go ahead and get the coordinates of each of these points so we can determine if this is a function. So I'm going to start all the way to the left. Looks like I have a -3, 1 for my first point. This point here looks like that's -2, 1. This point here is a 0, 1. And what's this one over here? 3, 2. Okay, so let's list out our x values. I like to go left to right usually, least to greatest. So -3, -2, 0, and 1. Do any of those repeat? So is it a function? Yes. Okay, so I do that before I even look at the y values, just to help me. And then the range, I'm just going to list those. So I have 1 3 times. I don't need to write it 3 times. I can write it once. And then I have the 2. In the domain, I don't know. That's a good question. It should be a 3. Okay, another way that we can determine if something is a function from a graph is using this vertical line test. So the vertical line test will answer if something is a function. You'll draw a vertical line, or even if you're looking at your screen, you can kind of just take your pencil vertically across the screen. If it hits the function more than once, then it's not a function. Okay, if it only intersects it one time, then it is a function. So if I look at these examples here, I can draw a vertical line, hit it one time. Okay, so this intersects the graph only once. So here we would say that, yes, this is a function. Now in this graph here, if I come over to the side and I go right here and draw this vertical line, I am going to end up hitting the graph more than once. So here we're going to say, no, this is not a function. Okay, and let's think about why with this vertical line. Why does this work? Let's say this is our graph, so this is the point 1, 2, 3, 4, 5. And this is 1, 2, 3. So this is the point 5, 3. And this is the point 5, negative 3. The x values are repeating. Remember that vertical line has the same x value at every single point. So the vertical line will help tell you if any of the x's repeat. So, oh, I didn't even see that part right there. So yes, it's a function, not a function. Okay, then when we're looking at a graph, we're going to be asked if it's a function. We're also going to be asked to find the domain and range from a graph. So we're going to look at some examples here. So to find the domain of the graph, we're going to go left to right. So I'm going to draw a graph here. All right, so we're going to start at negative 5, 0, just to help us out here. And we're just going to go like that. Okay, we want to find the domain and range of this graph. So for the domain, what we want to do, and I have some extra graphs here. I'll write over this one here. Okay, so for the domain of a graph, I think it copied extra here. What you're going to do is you're going to write in interval notation. Okay, so what you'll do is you'll either do a parentheses or a bracket, and then you're going to go your leftmost x. You're going to go left to right. So left x, comma, your rightmost x. Okay, pretty much left to right is what we do with inequalities on the number line. So same thing. And then parentheses or bracket. So if I look here, my leftmost x value is this negative 5. So negative 5 is my leftmost x, and then I do have an arrow going off the graph. So if on my lab math you have any graphs that are just going off the screen and there's not an arrow, assume it's an arrow. Okay, so if it goes off to the corner of the graph, it's an arrow. So that arrow is going towards infinity. So our rightmost x is infinity. Now we know in interval notation that infinity always gets a parentheses. It's an ugly infinity. I gotta fix it. It's a little better. Okay, so infinity always gets a parentheses. With the negative 5, you have to look at what's happening on the graph. Okay, so is the point negative 5 part of the graph? Yes. It has a closed point here. So think closed circle, open circle. This will get a bracket. So open circle would not have a bracket. Closed circle would. I'll show you an example where it won't on the next example. Now the range, okay, now the range is the y values. So y is up and down. So for the range, you're going to start with either a bracket or parentheses, and then you're going to go your bottom. So you're going to start from the bottom and go to the top. So your bottom y, and then your top y. And then either a parentheses or a bracket. So now I'm going down, up. So the first point on this graph is still this negative 5, 0. Now we're taking the y value. So the y value of this is 0. And then that's going up to infinity. So 0, infinity is my range. Again, 0 gets a parentheses. Same thing with the circles. It's closed, so 0 will get a bracket. And then, is this a function? Yes. Give you a second there. We'll draw our next graph. Bottom to top. Okay, our next graph, let's go with, make some 1, 2. So start at -2, draw an open circle. -2, 0. And we'll just go over here, maybe, let's do like a weird thing here. So 1, 2, 3, make a point at 3, 0, or sorry, 0, 3, and 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 2. All right, so we're going to go like this. Oh, connect the dots. Okay, so what we want these actual points, so we know the values here. So this is -2, 0, this point here. This is the point 0, 3. And then this is the point 6, 2. Okay, so we want the domain and the range of this function. So let's start with the domain. Okay, my leftmost x value is going to be what? -2, yes. Start on the x-axis. You get to this point first. So -2. My rightmost x value, so now I'm going to go along the line and go to the right. Farthest right value, 6. Now let's look at the circles. -2 is an open circle, so that will get a parentheses. 6 has a closed circle, so we get a bracket. So the domain of this function is -2, 6. Parentheses on -2, bracket on the 6. Now let's do the range. So we're going to start on the bottom. We're going to work our way up. What's the first point we get? This -2, 0. We want the y value. It's 0. Okay, then we're going to go along the graph. We're interested in the highest point that this graph goes to. So what's the highest point here? This 0, 3. So we want the 3 value there. That's going to be the highest point. Then we look at the circles. The 3 has a closed circle. That will get a bracket. The 0 has an open circle. It gets a parentheses. Is this a function? Yeah, this is a function. All right, let's turn the page and we'll do 2 more. All right, this one, you can kind of draw this anywhere you want. I just want a line going off and on the page, or off both sides of the graph. And then I'm going to draw a circle for this one here. So we're going to, let me give you the points for the circle. Or actually, let me draw it and we'll see where it falls. We'll go like that. Okay, so let me see. 1, 2, 3, 4, 5, 7, 8. This looks like this is -8. This point here, -8, 2. So then this is going to be 1, 2, right here on this side. And then this bottommost point is 1, -3.5, -2. And this is going to be -3.5, 1, 2, 3, 4, 5.5. All right, and we want the domain and range of both of these. Okay, so on my pink line for the domain, if I go left to right, what's my leftmost point? Yeah, it's an arrow, right? Which side of it is the infinity on? This is negative, right? Okay, and my rightmost point? It's also going off the graph. So this is domain -infinity to infinity. What about the range? Same thing, right? Bottom goes off the graph, top goes off the graph. Any linear equation is going to be like this. So any line, okay, not the straight, not the horizontal vertical, but any line with a slope. So anything that's in y equals mx plus b form, or ax plus by equals c, if it has a slope, domain and range -infinity to infinity for both. Okay, let's look at this example here. So if I go left to right on the circle, what is my leftmost x? It's that -8 right here. What's my rightmost x? 1. Good. When I'm doing a circle, sometimes what I'll like to do is I'll just draw lines on either side and just go down to the x values. So you get those constraints left to right. Now, there aren't dots on a circle. I put the dots there because I was giving you guys the points. But a circle, think about what the bracket means. It means less than or equal to, or greater than or equal to. So it means including that value. So -8 and 1 are actual points on the circle, which means when you're doing domain and range with a circle, you're going to have brackets because we want the actual points. The only time you're not going to have brackets on a graph is if you have an actual open circle showing that graph. Once you get to like calculus, then you're going to have approaching values and things like that, but you don't have to worry about that for a couple more classes. For my range, what's my lowest y value here? -2. And then my highest one? 5.5. Good. And then these will get brackets. So circles get brackets. I want to do one more, or actually two more with you, with just the vertical horizontal lines, just to show you what those domain and range are for your reference. So just draw a vertical and a horizontal line. Okay, so let's just say that this vertical line is, here's our graph. So this is x equals 3 is the line. So it goes through this point here, 3, 0. And I want the domain and the range for it. Okay, so for the domain in this case, I'm not going anywhere. I'm left to right. So in this case, the domain is just a single value. What's that single value? It's just 3. So in this case, it's just a bracket 3 because it is that single value. So it's not always going to be an interval. And the case where it wouldn't be an interval is these horizontal vertical lines. Now, what would the range be here? Goes up and down, right? All the way off the graph. So the range here is that negative infinity to infinity. Okay, now let's say this is the graph y equals 3. So it goes through the point 0, 3. Now in this case, the domain left to right, we're going off the graph in either direction. So in this case, the domain is negative infinity to infinity. Now our range is a single value. Okay, so you'll get a single value with either a horizontal or a vertical line for the domain or range. Any questions on those? Okay. Sometimes on the homework, you'll have to click on the graph and zoom in just to see the points a little bit better. Okay, so this last little part of Module 3, we're doing function notation. So function notation, you're going to have an input that's going to be f of x with an output y. So it just means that y is the same thing as f of x. They can be interchanged. Okay, so it could be read f of x. You'll see f of x instead of y. It's the same thing on your function. The parentheses does not indicate multiplication. It indicates f of x. So it indicates what is being put into, because it's an input function, into the function. And then letters are going to notate the functions. So if you look at this example here, you have a function that's titled f of x, then you have another one, g of x, and then you have another one, h of x. So that's just like saying function 1, function 2, function 3. They're just titled with letters. So if you have this here that says find f of 2, it means go to the function labeled f and plug 2 into it. Okay, if it says find h of 3, then you'll do the same thing. So we'll actually add that and h of 3. Okay, so to evaluate a function like that, so we have find f of 2. What we're going to do is that we're going to take our function f of x and we're going to plug 2 into our f of x function for every x. And then we're going to simplify. So our f of x function is f of x equals negative 2x plus 3. So we're going to say f of 2 equals negative 2 times 2 plus 3. Now when we simplify, we're simplifying the right side only. We're not solving for anything. So all we're doing is on this side, we're going to go negative 2 times 2 is negative 4 plus 3 is negative 1. And we're going to say f of 2 equals negative 1. We're done there. We're not solving for f. We're saying this, the way this reads technically is the function evaluated at 2 is negative 1. If I were to take that and put it onto a graph, this would be the point 2, negative 1. Okay, and then let's do h of 3. So this says go to the h of x function and plug 3 in. So our h of x function is negative 5x squared minus 8. So that means we're plugging 3 in for our x value here. And then we're going to simplify. So we'll go order of operations. 3 squared is going to be 9. Then we'll do negative 5 times 9 is going to give us a negative 45. Minus 8 will give us a negative 53. So we say h of 3 is negative 53. So now what I want to do is just give you guys a few minutes, and I want you to do 1, 2, and 3. It's all for the same function, for our g function, but you're plugging 3 different values in and simplifying. So do that real quick, and then we'll check on that in a few minutes. Okay, looks like majority of you are done, so we'll go ahead and start working on this. So we have, let's see here, so g of 1/2, so we'll go ahead and plug that in. We have 2 times 1/2 squared minus 1/2 plus 1. I noticed a lot of you didn't bring calculators, so let's go ahead and do this by hand. So 1/2 squared is 1 squared, 2 squared, so it's going to be 1/4. 2 times 1/4 minus 1/2 plus 1. So then 2 times 1/4, what's that going to be? 1/2, yeah, because it's 2 times 1, which is 2, over 4. So that's 1/2. So you get 1/2 minus 1/2 plus 1. So 1/2 minus 1/2 is 0. So these just cancel out. So our answer there is 1. So g of 1/2, 1. All right, next one, g of negative 2. So we have 2 times negative 2 squared minus negative 2 plus 1. So we'll start with the exponent. Negative 2 squared is going to give us a positive 4. So we have 2 times 4 minus negative 2 plus 1. That's going to give us 8. Minus a negative 2, that's going to be plus 2 plus 1. So 8 plus 2 plus 1 gives us 11. Okay, so that's this double negative right here. Turns into a plus. So g of negative 2 equals 11. Okay, then g of 3. Let's see what we got here. 3 squared minus 3 plus 1. Okay, so 3 squared is going to be 9. So 2 times 9 minus 3 plus 1. So 2 times 9 is going to be 18. 18 minus 3 is 15, plus 1 will give us 16. So there we're getting g of 3 equals 16. Does anybody have any questions on that? All right.